Right guys, I'm just going to show you how a carbocation is formed. Okay, so firstly, let's just have a look at the word carbocation. Okay, so a cation, we know that a cation means a positive ion. Okay, so we now need to look at what carbocation means. So carbo, if we look at that, it should be something related to carbon. Okay, right, so it's a cation of a carbon, and we're going to have a look at how that cation of the carbon is formed. To understand that, we need to have a look at the bonding that one carbon atom forms. If you look at your periodic table, carbon is from group 4, okay? The group number indicates the number of electrons in the outer shell of an atom, okay? So if carbon is from group 4, what that means is that it has 4 electrons in its outer shell. Right, so this is what it would look like, okay? So 1, 2, 3, 4, okay? So we've just drawn the 4 electrons in the outer shell of carbon. When a bond forms, that's because electrons are being shared, okay? More specifically, covalent bonds, okay? So in covalent bonding, it forms because of shared pairs of electrons, okay? So it's when an atom shares an electron with another atom, okay, and the other atom shares an electron with the atom, okay? And so if we just have a look at that, we've got hydrogen, okay? Hydrogen is from group 1, so it has 1 electron in its outer shell. In order for it to become stable, it will need 1 more electron. Carbon has 4 electrons in total. In order for it to become stable, it will need 8 electrons in total, okay? So if we just attach a hydrogen, this is what it would look like. The dot is showing you the electron from hydrogen, okay? And then, okay. Right, so this is methane. So methane is CH4. If we were to look at the bonding, okay, I'm not showing you the proper shape for a methane molecule, but just to show you the bonding, this would look like this, okay? Right, so as you can see, one bond is a shared pair of electron, okay? So one bond represents a shared pair of electron. So right now, if we look at this, carbon is happy and hydrogen is happy, okay? They both have a stable outer shells now, okay? So hydrogen is happy with 2 because in the first shell you can only have up to 2 anyway. Carbon is also happy because it has 8 electrons in its outer shell. So if we look at this now, let's have a look at how a carbocation is formed, okay? So a carbocation is formed when we remove a bond, okay? So let's just get rid of this bond, okay? So when we get rid of that bond, what we're also getting rid of are these, is this shared pair of electron, okay? Because one bond represents a shared pair of electron. So when that happens, what will happen is the carbon is electron deficient now because it's lacking electrons. So if we look at this, it has 1, 2, 3, 4, 5, 6 electrons in total in its outer shell, okay? Any electron that's being shared is the number of electron in its outer shell. Now, because it's electron deficient now, what's going to happen is the carbon will become positively charged, okay? And it will just have a positive charge on the carbon. So let's just rewrite this. Let's just draw this again. Okay? So we'll have this positive charge, okay? This charge is what makes this a carbocation, okay? So it's a cation of a carbon basically, okay? So a carbocation is formed because we're losing one bond, because when we lose one bond, we're losing a bonding pair of electrons or shared pair of electron that forms the covalent bond. The carbon's becoming electron deficient, therefore it becomes positively charged. So this is how a carbocation is formed, okay? Next lesson we will look at how these carbocations can be used in a reaction.